Samantha, working as Associate Research Analyst at IndustryARC. The agenda of today's webinar is Global Changing Dynamics of Manufacturing Countries Map and Robotics to lead the Industry 4.0 initiative. Going forward, I would like to focus on types of industrial robotics, emerging application in manufacturing sector, increasing penetration of vision-guided robots, integration of robots in assembly line, changing dynamics of industrial safety standards, extensive investment on R&D, and Industry 4.0. In addition, the favorable government initiatives in developing and developed economies, followed by the reforms in various connected manufacturing standards, are also been highlighted, which are set to offset the present industrial robotics market constraints and pave the way towards growth in future. Starting with the introduction of industrial robotics and various types. Industrial robots are multi-purpose, programmable and adaptive manipulators capable of performing repeated or routine tasks at a higher speed, efficiency and reliability as compared to human workers. These machines are capable of performing continuous operations at high speed with greater accuracy, efficiency and reliability. The global increase in demand of non-consumable goods since the past decade has led to the prominent development and widespread adoption of these machineries in the manufacturing sector. Moreover, increase in labor cost in developed economies is also leading to a paradigm shift of these robots for uncompromised throughput, higher safety and operational reliability. Further, with the increase in aging population and stringency in industrial safety regulations, manufacturers are opting for these robots for operating in factory floor. Industrial robots are of various types, which are designed with respect to the end-use applications. These types include articulated robot, cylindrical robot, linear robot, SCARA robot, and a few other. Broad spectrum of applications served by these industrial robots are welding, painting, assembling, inspection, material handling, packaging, and so on. Moving forward to emerging applications of industrial robotics in manufacturing sector. In recent years, industrial robots have been developed which are capable of machine tending applications, which is a dangerous job on factory floor. These robots are been designed to pick and orient the object on the machine table with uncompromised accuracy and efficiency. The process of tending performed by these robots is similar to that performed by a human worker on the factory floor. Inspection and testing industrial robots are being equipped with high-end 3D vision systems for increasing the accuracy of the process, especially in consumer electronics sector. Autonomous intelligent vehicles, which are the next generation AGVs, are stepping into the picture. These mobile robots are equipped with enhanced vision guidance systems and are capable of obstacle detection and planning optimal route to the destination with the payload and without any human intervention. The next part of the webinar is increasing penetration of 3D vision guided robots in the manufacturing sector. 3D vision guided robots are witnessing gradual penetration in assembling, inspection, material handling and packaging applications. In assembling applications, these robots are capable of identifying a particular part and orient it at a particular position for assembly. This sector is witnessing prominent adoption of 3D vision guided robots, especially for electronics manufacturing, which requires high precision and accuracy. Material handling robots are also being equipped with 3D vision guidance systems for effective identification of parts or products autonomously. Going forward, I would like to discuss on integration of automated robots in assembly lines. Automotive companies are opting for highly automated robots in assembly lines for increasing the production capacity of the firm, catering to the increasing demand of vehicles. Automated welding robots perform the fabrication of vehicle chassis at high speeds with unmatched accuracy. Down the assembly line, the paint and inspection of vehicle chassis is also being automated to higher extent with minimal human intervention, escalating product reliability to significant extent without sacrificing the speed of the production. Apart from this, collaborative robots or cobots are also being developed to work in close collaboration with human workers on the factory floor. These robots have prominent potential of adoption in high volume production, especially in consumer electronics and automotive industry. Ford Motor Company is one of the early adopters of cobot in their assembly lines. The company's assembling plant in Cologne, Germany employs KUKA LBR IIWA in the assembly line to work side by side with factory workers for carrying out simple, tedious and heavy processes. Tesla Motors is also one of the major adopters of industrial robots for its Gigafactory. to cope up with the increasing demand of electric cars, it is using fully automated robots in its assembly line to ramp up its production. Going forward, I would like to discuss the industrial safety standard, shifting the focus to these robots for operation in hazardous environment. Stringent industrial safety regulations are also leading to paradigm shift to industrial robots for operations performed in hazardous areas or factory floor. This is enhancing the safety of workers without compromising the production. Material handling robots are used for conveying raw materials, semi-finished and finished products to specific sites in a production plant. These robots increase the reliability and safety of operation by reducing human intervention to minimum, thereby reducing the chances of human error which may otherwise result in significant loss of property or life. Extensive investment on R&D of industrial robotics by prominent players, government and universities. Prominent growth in adoption of industrial robots in recent years is attracting extensive investments for development and manufacture of industrial robots. Key players of the robotics industry, government of developed economies and universities are focusing for development of advanced robotics technology in industrial sector. Collaborative robots or cobots are being developed which are capable to work collaboratively with human workers. Cobots are presently targeted to logistics and assembling applications where these can interact and work in coordination with human workers, increasing the productivity. These robots are small, cost-effective and highly adaptive as compared to conventional ones, and these features are set to drive its adoption in small and medium-scale enterprises with higher impact. Coming to the last part of the webinar, Industry 4.0. A coalescence of operational technology and information technology is set to pave the way for industrial robots. Industry 4.0, the fourth industrial revolution, is set to drive the adoption of industrial robots. Industry 4.0 is based on collaboration of information technology and operational technology, which is witnessing widespread adoption all across the globe. In this highly competitive market, companies are depending on IT to increase its operational efficiency. Industry 4.0 provides a platform for machine-to-machine and machine-to-infrastructure communication for data sharing and storage. This raw data is further processed and evaluated by the program central units in real time to optimize the production process without compromising with the machine service. Industry 4.0 includes several technologies such as machine condition monitoring, predictive maintenance, machine learning and many others to optimize the productivity and operational cost. This is set to drive the adoption of industrial robots in the future. Talking about government initiatives in some of the major and emerging manufacturing hubs. With the initiatives such as Make in India, the manufacturing sector of the country is estimated to flourish. Further, with the increase in foreign investments, small and medium-scale manufacturers would get the opportunity to adopt automation, which would further pave the way for industrial robots as well. In 2015, the South Korean government offered Samsung a $14.8 million investment to develop factory robots so as to cope up with the increasing labor cost and perform complex tasks in mobile manufacturing and other consumer electronics domain. Two major robotics projects are being funded by Japan's Ministry of Economics, Trade and Industry, which aims for developing advanced intelligent robots and living assistance robots. These robots are analyzed to avail new heights to industrial and factory automation through gradual penetration into the service sector. Japan's Industrial Value Chain Initiative for Reformation in Smart Manufacturing is set to drive the industrial and factory automation to significant grants. Japan has stepped into an initiative to open world's first robot farm introducing automation in agriculture at commercial scale. Agriculture sector has been analyzed to witness negative impact due to labor shortage owing to aging population, and with the introduction of automation, the impact will be significantly reduced. Government support for the integration of cheaper and more efficient industrial robots is a good news for factory owners in China, who are facing a global weak economy and a slowdown in domestic demand. Taiwan is also witnessing significant development in intelligent automation featuring sensing, computing and machine-to-machine communication with easy and fast programmability for extended usability. Looking into some of the standard and compliances of Industry 4.0, cyber-physical systems such as IIoT, Industry 4.0 and so on are to stand up as a self-managing production process in future. These are assessed to be based on open software and communication standards which would assess the growth of the market. These standards allow multiple sensors, actuators, operators, machines, equipment, systems and other related products to interact or share data with each other. Future automation systems are to adopt open source, multi-vendor interoperability software applications and communication standards which are similar to the existing cell phones, internet and computer. Industry 4.0 acknowledges this by leveraging the existing standards such as ISA 88 batch standard, ISA 95 Enterprise Control System Integration Standards, OPC UA, IEC 611313, PLC Open and so on. The harmonization of standards took a forward leap last year in March when the representatives of German alliance platform Industry 4.0 and the US-based Industrial Internet Consortium met to explore the potential alignment of their respective architectures. Concluding the webinar, the major drivers for industrial robots market are increasing stringency in industrial safety regulations and growing adoption of these machineries in the manufacturing sector. That's it from our end. Please revert us your queries. For more information on industrial robots market, please visit our website. Thank you for watching.